Hello friends, welcome to this video. In this video, we'll look into a HackerRank problem from Java data structures, and this problem is about Deque. It's a medium level problem. So here the problem starts with the description of a Deque data structure. It talks about Deque of abbreviated as Deque. It's a doubly ended queue, and it's an abstract data type that generalizes a queue. And elements can be removed either from front or from back. The Deque interface has the following implementation, and you can view more details about Deque in the documentation in the deck. So you see here add first, remove first, gets first methods. This is for operations on the head, and on operations to the last element of tail, you have add last, remove last, get last. So these are some of the important operations. But yeah, let's look into the problem now. The problem is given an integer n. N is the, the size of input, and then there is another subarray size which is m, and both n and m are between 1 and 100,000, and m will be less than n, and you are given an array. So for example, sample input 6 and 3, and you have to find the largest or the maximum number of unique integers among all possible contiguous subarrays. Contiguous subarrays are array which will be uh, continuous. So elements are continuous. You don't skip any elements. So here an explanation for this problem is, so here the size of the array is 6, size of subarray is 3, and we have to find various subarray. For example, 535. It has two unique elements, 3 and 5, and so it's not the largest number of unique elements. Then we move to the next 352. We see again, this has three unique values, and 3 is the size of subarray. This could be the maximum. It's maximum because yeah, you can't have the subarray unique elements which is more than the size of the subarray. So one optimization we can break from here. Other one, yeah, but still it proceeds 523, and this is again having three unique elements, and then 232. It has two unique elements, 2 and 3. So this is about the problem, and they have a template code. So let me reset the code. Yeah, it's already it was resetted. So here I see there is some hint use. They have used a Deque and array. So probably this has integers. So we can just declare it to use integers, and now there's already a code to scan the standard input, which is from keyboard. It can read the value of n, size of the array, from keyboard and insert it into variable n, and same for m. And they have done everything here. So yeah, what we can do is we have input can close after this loop because the input reading is there. This will save the resources. Now to solve this problem, the logic is we can keep inserting these array elements into a Deque or Deque, and once we reach the size m, we count number of unique elements. And so here the way we can count the unique element is insert all the elements to the set as well and see the size of the set. So that's the easiest way to count number of unique elements. And then we can keep track of the maximum value. and we can keep removing the first item as we reach size M, and you insert one more item and you remove from first the item, and then again see the size of unique elements by seeing the size of set, and you repeat this process. So as after you reached M size, you remove from first and insert at the end the new element. So this is a great way to create sub-arrays of a particular size in using array. So you can use Deque and you can keep inserting at the last and remove from first, and keep this way you keep moving from first to last, and you get all the sub-arrays. And as you go, you keep track of the size of unique elements and track of maximum number of unique elements, and if you see a higher number you replace max, and then at the end you report the value of M. So let's write the code for it. It's a straightforward logic. So here as they have already provided a deck, I will also create a set for integer, and we call it so we can use hash set implementation. We don't need sorting, so that should be good. Hash set should be good. Now here I have got an element. So what I do is we have the deck, we add first, add last, and we remove from first. So we add last. So you can use simply add as well, but yeah, just for clarity, I write this. And at the same time, I will add to set as well. Now, if I have reached, if the size of Deque is M, so then I can just see how many unique elements are there. So I got the first subarray. Now I can say set size, and this one I can store it. So in some variable, I can say int is current unique, then initialize this to 0, and I can also use a max, which I can initialize this to 0. 0 is the minimum possibility of a unique number of elements. Is even 1 is the minimum possibility, so max will equal to 0 is very safe. Right? Is no need to use integer dot main value. Yeah, 0 is sufficient. Here centered size, and this one we say current unique. Now we got the current unique, and if max is less than current unique, then you say max equal to current. And now I got the max, and then what I can do is I can now remove element from the front. So I say deck dot remove first. No, it will remove the first element. There's no parameter, and probably it will return an item which is first. So I can just store it first, and I can think of removing it from set as well, provided set do not contain these number. So if I say Deque contains first, in case there is more occurrences of this first, then I can't remove it from set. So I keep the set as it is. But if it does not, your deck do not contain the same element, so in that case you can remove from your set also the particular item. So this way now you are now ready to take the next element in the next iteration. So here in the next iteration you will get another element which is added, Again, the text size will become M, and then we can check size of the set, and then finally, once you're out of the loop, we can print value of maximum value. Now, another optimization I see here is max if max is equal to M. You do not have to look further because that would be the maximum size. So you can simply break. So this way, you need not have to go further iterations. So here I see here 3 is the number of unique elements. Now 3 is the maximum because 3 is the size of M, and you can't get 4. So I just break from here. This way, our code will run faster. So now this is all about our solution. So let's try compiling this and see if there are any compilation error. I see there is no compilation error, and it's returning the expected output for the sample test case which have been provided. And let's submit this code and run it for all test cases. See if this works. So yeah, it works with all the test cases in the system, and this solution is accepted. So you see here, using Deque, getting subarrays is so simple and easy. And using set, it's very easy to count the number of unique elements. So this exercise demonstrates the use of both dep and set. And hope you enjoyed this solution and problem. And in case you have any further queries, feel free to write in the comments. And do like this if you enjoy this problem. And do subscribe to my channel Dev Skills if you want to look into other programming problems and other tips for developers. Thank you.